So dear students, today's topic is amino acids. Okay. So first we'll discuss what is amino acids. Amino acids are the compounds that contain at least one carboxyl group and one amino group within the same molecule. Okay. So in a molecule, if both the amino group and carboxylic acid is present, that is called amino acid. So these are the building blocks of proteins. Amino acids are basically the building blocks of proteins. So you can see it. So this is alpha amino acid. So this is your acidic group and this is amino group. So this amino group is present with the alpha position of this carboxyl group. Okay, so this is alpha amino acid. So next is deuterion or dipolar nature of amino acids. Basically amino acids had a basic amino group and an acidic COH group. You can see here. Okay. So this acid means acidic group, that H plus will attack to this amino group because this amino group is basic and it will form internal salt. So this is salt basically, RCHN plus H3CO minus. So a cation is there and an anion is there. Okay, so that's why it is called deuterion. Deuterion means both positive charge and negative charge is present in the same molecule. That is called deuterion. So what are the evidence in favor of dipolar ionic structure? So how can you confirm that these amino acids are deuterion? Means they have salt-like structure. One positive charge and negative charge is present in the same molecule. How can you prove this one? So these are the evidences. So first evidence is this amino acid has high melting point. These are highly soluble in polar solvent. Amino acids are basically insoluble in non-polar solvent because they are salt-like structure. That's why they will be soluble in polar solvent like water. Okay, and they have large dipole moment and low value of acidity and basicity constant. Okay, so these are the confirmation. So we can confirm that our amino acids are deuterion, means they have both positive charge and negative charge. Okay, so these are some confirmation. Next is the very important question: what is isoelectric point of amino acids? What is isoelectric point? So isoelectric point is at a pH at which an amino acid does not migrate to any electrode in an electric field. Okay, because you see, so this is neutral pH. So this is deuterion. In basic pH, what will happen? Means in presence of base, so this N plus H3 will remove one H plus. One H plus will go and that will form an anion. You can see, so this is anion. Okay, and in acidic pH, means if you use an acid, then what will happen? This carboxylate ion will accept a proton and that will form a cation. Okay, so the important thing is here, in basic pH, your neutral amino acid will form an anion, and in acidic pH, this neutral amino acid will form a cation. Okay, then what will happen? So in basic pH, basically what will happen? So this anion will move towards cathode. So if you apply an electric field, then what will happen? So this anion will move towards anode. Okay, because it is negative, so this will move towards the positive electrode, that is anode. And in acidic pH, so this is cation and this cation will move towards cathode. Okay, so if you apply electric field, so this cation will move towards cathode. Okay, so isoelectric point is a special pH, a particular pH that an amino acid does not migrate to any electrode. Okay, means so this amino acid will not move towards any electrode, either your anode or cathode. Okay, so that pH, that special pH or that particular pH, that is called isoelectric point. Okay, so in next class we will see how can we synthesize this amino acid. There are various methods. Okay, so today's topic was you should know what is isoelectric point and what are the evidence in favor of dipolar ionic structure of amino acids. And what is amino acids? Okay, amino acids can be different types: alpha amino acids, beta amino acids, gamma amino acids, and delta amino acids. Okay, but specially in our body there are 22 amino acids are there, and they all are alpha amino acids. Okay, in next class we will go to the synthesis of amino acids. Okay, so thank you all.